Hey guys, welcome to the first lecture that we're going to use the new extreme science curriculum, which now is actually called SOS Science. It's by the University of North Texas through the Teaching Quality Grant. A little disclaimer for those of you not in my class watching this publication. After you finish all the notes for this PowerPoint, you're going to write down your questions on the left, and then the most important thing about your notes is that you are going to summarize. So again, on the right side of your notes, I want you to write down force, and then go ahead and define it with what you think a force is. And let's start off with a misconception. A force is necessary to keep an object moving. Is that true or false? You'll write that down in your journal underneath what a force is. Is a force always necessary to keep objects moving? If you selected false, you did perfect, because Newton's first law of motion states that objects in motion stay in motion in a straight line unless acted upon by an unbalanced force. And outside forces such as friction, gravity, magnetic force, electrical force, and air resistance slow and stop objects. Think about a soccer ball. What is the force that slows down a soccer ball? Why doesn't it move on the grass forever? If you said friction, you're exactly right. We have friction on Earth. It's because of the atmospheric pressure. It's because of gravity that pulls down on the ball and slows it down against the rough surface of the grass. However, if we were in space, you would have no friction and no gravity when you're in the dark matter area of space, and therefore in space, if you kicked a soccer ball, it would travel in a straight line at the exact same speed it left your foot forever, unless it was acted upon by an unbalanced force such as the gravity of a planet or a moon or a star. So true or false? Again, this is on the right side of your notes. If an object is at rest, no forces are acting on it. So think about a book resting on a table. Are there forces acting on that book at this time? If you said false, you're correct. There are many forces acting on it. There's gravity, air pressure, etc. But they're all balanced. That's why you don't see the book moving. Gravity is pulling the book down to the table. The table is pushing against gravity to keep it up, and so forth. So you won't see movement. So let's start with vocabulary. A force, this is the definition you've had since you started learning about forces, is that it's a push or a pull on an object. Again, this goes down on your notes section of your Cornell Notes. A force is a push or pull on an object. So push or pull. So basically a force is anything that interrupts the natural either movement or non-movement of an object. It either slows an object that's moving down, or it changes the object's direction, or it is completely balanced, and we have a force where you see no movement but you know force is there, or a force on a stationary object where it's sitting still but you use force to remove it or interrupt it from its stillness. Equilibrium. Equilibrium is a condition where all forces are balanced. So think of a tug-of-war match where you have the exact same strength on each side and the rope is not moving. Well, the forces that are pulling on one side equal the forces that are pulling on the other, and so the rope won't move. And so the system is in equilibrium. And then we have friction. Friction is a force when two surfaces, and more importantly, friction is caused when their surfaces are irregular, so they're not exactly smooth. It is always in the opposite direction of the motion. So if I kick a ball forward, friction is acting in the opposite direction, so it's pulling the ball backwards. And that relates to Newton's third law. Next we have speed. Speed is distance over time. So distance over time. And get familiar with writing out a triangle for you to remember this. And if distance is over time, I'm going to put D here. I'm going to put time right here. I'm going to put speed right here. These are the three variables we're working with. So if I'm trying to calculate distance, what I would do is I would cover up with my finger distance, and I would have S is next to T, so distance equals speed times time. If I wanted to find out time, I'd cover up T, and I have time equals, and see the D is above the S, so time equals distance divided by speed. And then finally, if I wanted to get speed, I'd cover speed up, and all that would be there was speed equals distance divided by time. Velocity is the speed and direction of an object. So a speed might equal 40 kilometers per second. That means I go 40 kilometers every second. But a velocity would equal 40 kilometers per second, and then we'd have a direction, either north, east, south, or west. So velocity has to have a speed with a direction. And then finally we have acceleration. Acceleration is a change in either the speed or the direction of an object. So speeding up or slowing down are both examples of acceleration. But let me ask you this. If I'm in a car and the car is driving around in a circle and the speed is constant, meaning that it's driving around in a circle on cruise control at, let's say, 10 kilometers per hour. So if a car is driving around in circles at 10 kilometers an hour, is it accelerating? Write that in your journal. Most people would say no, it's not accelerating because the speed is staying the same. But remember that acceleration is a change in either or direction. So is the direction of this object changing? Absolutely it is. And therefore, we have acceleration present. So let's look at Newton's first law. Newton's first law says that an object stays in motion in a straight line unless acted upon by an unbalanced force. So again, if we use our space model, and this is going to be Earth, and we're in space, let's say we're on the moon. If we're on the moon and we kick a soccer ball out into space, once it leaves the gravitational pull of the moon, it's going to continue in this same direction at this same speed forever unless acted upon by an unbalanced force. What are some unbalanced forces in space? Remember that gravity is something that all objects possess, and it increases with size, and it increases the closer you get to something. So what would slow down the ball in space? I want you to write that down in your interactive journal under your notes section. Remember from before, what is a push or pull? What do we call that in science? We call that a force. So a force will cause an object to speed up, slow down, or change directions. Again, this has to do with Newton's first law. So let's look at when forces are balanced. Okay? If an object is at velocity is 0, then it's going to stay at rest, and therefore it's completely balanced. So if there's no speed and no direction and the object is not moving, we say that the object is at rest and the forces are balanced. If an object is in motion and therefore the velocity is not equal to 0, then it's going to stay in motion at the same speed and direction. It's balanced. So even though the object is moving, if there's no friction, no gravity, no air pressure, none of that, it's going to be still balanced because there's no forces that are speeding it up or slowing it down. So basically, objects just keep on doing whatever they're doing unless they're acted upon by an unbalanced force. That is the easy way of putting what Newton's first law is. Objects just want to do what they're doing. So a car that's moving, it just wants to keep moving and wants to go that same speed in that same direction, but we do things that change its velocity. We brake, we hit the gas, and we turn the wheel. All of these things make my forces unbalanced. So when I brake, I'm accelerating because I'm slowing down. When I give gas, I'm accelerating because I'm speeding up. And when I turn the wheel, I'm accelerating because I'm changing the direction. So if none of these things change and I don't have all the other forces that are acting on me, then I'm balanced moving in a direction, but I want to naturally be moving.